Hello, good day viewers. Today we are going to find a solution to these three problems, all under fundamental theorem of calculus. Remember yesterday we started with an introduction to the topic, which is nothing but a relationship or a connection between the antiderivative and the derivative itself. So this is what we have to evaluate today. We have d over dx of the integral from 2 to x of the function 2t dt. So one thing you should know here is that if this function is very difficult to integrate, you can just apply the formula I gave you yesterday, which stated that d over dx of the integral from a down to x of the function f of t dt, if at all this is a constant and this is x, you can always write it as what? F of x. Simple. So today we are going to apply this as well as the traditional way to see whether we're going to get the same answer, but only for this one. Subsequently, I will only apply this formula. All right, let's get started. For this one, the traditional way, we can integrate this function with respect to t. Just focus on this one alone. It is going to give us 2t squared. If you integrate it, then you divide by 2, right? So this is all the same thing as t squared. The limit is what? From 2 down to x. If you substitute the upper limit, you have x squared minus the lower limit, which is 2 squared. And this will give us x squared minus 4. This is just the integral of this function. But remember to differentiate it. So d over dx of x squared minus 4 will be equal to what? 2x minus 0, which is simply 2x. Can you see that? So it means that the whole of this is equal to 2x. And we have learned that if this is a constant and this is x, you can simply plug in the x into the function and you get the same answer. Which means that this is the same thing as plugging x into the function 2t, where you have to replace t with x. So it will be what? Just equal to 2x. Can you see? They're exactly the same. Okay, if this is true, we can just go ahead and substitute our x into the function, and this is equal to sine squared x. Simple. The same thing here. It will be what? Oh, this is the difference. Can you see that? We used to have a constant to the bottom, but can you see this is not a constant anymore? So how can we split it? We can split it into d over dx of what? Negative the integral from 5 down to x of the function t squared plus 1 dt. So finally, we can plug in x into the function, but make sure to attach this negative sign. So our final answer is negative root of x squared plus 1. As simple as that. So if you have constant to the top, it will be minus the function. But you have to plug in the x, don't forget. So subsequently, we are going to look onto problems that have limits different from a constant and x. It could be function to function, different things. Thank you for watching. Do have a nice day. Bye-bye.